Thank you so much. We're now going to review the fourth grade session 2 experiment. By now, if you are one of the volunteers, you probably are better served watching the video on session 1, which is going to tell you what happened the previous week. There is a short video on session 2 where the leader of the class would give an introduction to the experiment, and this is the actual experiment. Here is our makeshift knee. As you can see, the knee bends in all kinds of directions, and no human would be able to walk in this knee because the range of motion is far greater than what a normal knee should have. Because the kid in the book, the kid's name is Matthias, has fallen, tripped, and has an injury on his knee. And the other kids, Eric is the name of the kid who is going to brainstorm with his team. He takes what's in the backpacks of all the kids, and the class is going to be given a kit with all kinds of stuff, and they're going to try and design a makeshift knee brace. And so the reality of the matter is, by the time the kids are in 4th and 5th grade, there is no perfect solution. There is no perfect way of doing things. This is a rumble jumble of things, and each group is going to lead their team of kids to come up with something that works. So the most common reaction is going to be, well, we're going to wrap Matthias's knee in a t-shirt. Great. What else can we do? Well, that's not going to stay in place. Oh, well, I know what we can do. Let's put some tape around it and put some Velcro around it. Great. Well, what else can we do? Well, the problem is Matthias's knee is going to do one of these. Oops, that won't work. So we're going to put some popsicle sticks in there. Well, where do you put the popsicle sticks? Well, if you put the popsicle sticks here, that's useless. If you put it here, it's useless. If you put the popsicle sticks right about here, Matthias's knee cannot go up. It kind of makes sense to put some over there. What about this way? That's not how a normal human leg works, so you probably want to put some over there. So again, there isn't a perfect solution. And the answer is never to take duct tape and tape the whole thing. And the reason that is not the answer is because you will see in the 2nd grade presentation or the session 2 presentation that the brace has to meet 3 conditions. First, it should limit poor ranges of movement that the knee should not have. Second, it should be easy to take it off and put on. So it's not like once and done you take them to the ambulance or the emergency room. They're truly trying to solve the problem for the long end, even though in the book all that they have to do is get the kid to the car and get the kid to the hospital. What the kids in class are trying to do is think like a biomedical engineer. So if I needed an emergency one, I know what I'd do. I'd duct tape a whole bunch of the stuff and get the kid to the emergency room. But you really need to challenge them into thinking, how would you make it long term? You know, what are the ranges of motion that you can't have? This looks good, but is cloth what you want to have? Well, maybe somebody says, I'd like something stiffer. Well, the stiffer one looks like a pretty good deal. It probably prevents some of that movement, but maybe it prevents that movement too. And what you are very quickly going to see then is, hey, you know what? How am I going to get the Velcro to attach to each other? Well, you could try one of these. Thread the Velcro through this, and now you have a snap to take it on, take it off. Again, remember, we're not coming in with a perfect solution. There isn't a model knee brace of this is how things have to look. And you are going to have a brainstorming discussion. There are clips and pins. Sounds like a fantastic idea to poke some of these into the knee. Now, should you use it? Should you not use it? Should you put a rubber band? There is no perfect solution. Let kids brainstorm. And the question that you want to ask later on really is, hey, if you had more time, what would you have done different? And somebody is going to say, maybe I put a strap, maybe I put something else. So give the kids about 20 minutes, 25 minutes. Each group then speaks out about what their solution is, and you brainstorm the discussion and leave them with one very important thought. If you ended up with a knee brace that looks like this, and this is the best you could do, remember the engineering design process says go back and rethink it and redo it. So failure is okay, retry is okay. The second part is, you have to try multiple times before you get to the answer, and that is what STEM is all about. And that ends the discussion.